Okay, so now we're going to go through how to find out the nature of stationary points, i.e. whether a turning point is a minimum point or a maximum point. So let's look at an example. So let's say we had a cubic function. So f of x equals x to the power cubed plus 3x squared minus 2. We looked at in the last video how to find out the coordinates of these turning points. So what we do is we'd differentiate it, we'd find the gradient function, and we make that equal 0, because once we make it equal to 0, we can find out the points at which the curve is no longer increasing or decreasing. The gradient at that point is 0. So we do 3x squared plus 6x equals 0. We can factor out 3x here. That's right, so let's go by 6x, yeah, equals 0. So we find out that x equals 0 and that x equals minus 2. So the coordinates of these points are going to be 0. And then if we sub this back into the equation, 0 lots of minus 2. And then we got minus 2 lots of, I don't know why I'm saying minus 2 lots of, it's just minus 2 comma, minus 2. Okay, but then what if I told you that without sketching anything, which one's a minimum point and which one's a maximum point? So to do that, we have to come up with something called the second derivative. So the second derivative is, it's in the name, we're differentiating the gradient function. And why we're doing that? We're doing that to determine the rate of change of the rate of change. And that's even more confusing, but essentially what it means is we're trying to find out that at that point at which the gradient is 0, what is the rate of change? In the sense that, is it increasing or is it decreasing? Because that's gonna, and I know that that sounds confusing, because the whole point is that it's not that the gradient is 0, but we're essentially saying, is it going to increase or is it going to decrease? That's what we're trying to find out. So the notation for that is d squared y over dx squared. And that's going to be equal to essentially differentiating the gradient function, like I said. So we're going to get 6x plus 6. So what we're going to do now is we're going to substitute each one of our points. So we're going to substitute, we're only caring about the x value here. So for the first point, 6 lots of 0 plus 6. So 6 lots of 0 plus 6 gets us 6. Okay, 6 lots of 0 gets us 6, which is obviously a positive number. And by the rule, actually we'll come to the rule in a second, and for the other one, 6 lots of minus 2 plus 6, 6 lots of minus 2 plus 6 is equal to minus 6. Okay, and the rule is the algebraic rule. Another method is to find out points near each of the stationary points and see whether or not the curve is increasing or decreasing. But the rule is, and it's foolproof, if d squared y over dx squared, so the value, for example, for the 0, minus 2, the value is 6. If it's greater than 0, the stationary point is a minimum point. And if d squared y over dx squared, if it's less than 0, well, then the stationary point is the maximum point. Okay, so then we'd conclude and we'd give those reasonings, and we'd say that the 0, minus 2 as the d squared y over dx squared, the second derivative is positive. This is our minimum point. And then the minus 2 is going to be our maximum point. So I hope that made sense, and I'll see you in the next one.